Welcome to solverfy.
We are asked to use generating functions to explain the number of ways in which postage of our cents can be pasted on an envelope using 3-cent, 4-cent, and 20-cent stamps. In part A, we're asked to assume that the order of the stamps does not matter. So we have that 3-cent stamps can form any cent amount that is a multiple of 3. And so the generating function for 3-cent stamps contains all powers of x that are multiples of 3. So this is 1 plus x cubed plus x to the 6th and so on. We have that 4-cent stamps can be used to form any cent amount that is a multiple of 4. And so the generating function for the 4-cent stamps contains all powers of x that are multiples of 4. And so this is 1 plus x to the 4th plus x to the 8th and so on. We have that 20-cent stamps can be used to form any cent amount that's a multiple of 20. So the generating function for the 20-cent stamps contains all powers of x, which are multiples of 20. So this is 1 plus x to the 20th plus x to the 40th, and so on. So we have a total generating function, which is going to be the product of the generating functions for each kind of stamp. So this is 1 plus x plus, 1 plus x cubed plus x to the 6th plus, and so on, times 1 plus x to the 4th plus x to the 8th, and so on, times 1 plus x to the 20th plus x to the 40th, and so on. And this can be simplified to 1 over 1 minus x cubed times 1 over 1 minus x to the 4th times 1 over 1 minus x to the 20th. And this can be combined into 1 over 1 minus x cubed times 1 minus x to the 4th times 1 minus x to the 20th. And then in part B, we're asked to assume that the order in which the stamps are pasted on matters. So we have that on each draw, we have a chance to select a 3-cent stamp, a 4-cent stamp, and a 20-cent stamp. So on each draw, we have the series x cubed plus x to the 4th plus x to the 20th. So 3 different choices. And if we make n draws of stamps, then the generating function of the n draws is the product of the generating functions for each draw. This is going to be x cubed plus x to the fourth plus x to the 20th to the nth power and the total generating function is the sum over all possible draws. This is going to be the sum from n equals, well, we could have as few as 0 draws and as many as up to infinity draws. So x cubed plus x to the fourth plus x to the 20th to the nth power. We have it, we can rewrite this as 1 over 1 minus x cubed plus x to the fourth plus x to the 20th. And this can be rewritten as 1 over 1 minus x cubed minus x to the fourth minus x to the 20th. This is the answer for part B. In part C, we're asked to use our answer from part A to determine the number of ways 46 cents of postage can be pasted on an envelope using 3-cent, 4-cent, and 20-cent stamps. And we're told that the order the stamps are pasted does not matter. So we have that, turning to part A, our generating function, 1 over 1 minus x cubed times 1 minus x to the fourth times 1 minus x to the 20th. This is the same as 1 minus x cubed to the negative first times well, we can actually just write this as product. So the product, say, from k1 equals 0 to infinity of, and this is x to the 3k times the sum from k equals 2, k2 equals 0 to infinity of x to the 4k times the sum from k3 equals 0 to infinity of x to the 20k and we're just going to find the coefficient of x to the 46th. Since we're looking for 46 cents, so we're looking for k1s, k2s, and k3s such that 3k1 plus 4k2 plus 20k3 is equal to 46. And so You can plug in different values. You have from the computer algebra system, however, this can be more simply written as k1 equals 4n1 plus 2, k2 is equal to 2n1 plus 5n2, and k3 is equal to negative n1 minus n2 plus 2. Where n1 and n2 are integers, and so we have that if we take n1 to be, what's the smallest that k1 can be? Smallest k1 can be is going to be 2. So if we take n1 to be equal to 0, then we have k1 is equal to 2, k2 is equal to 5n2, and k3 is equal to negative n2 plus 2. And if we take n2 to be 0, we have k1 equals 2, k2 equals 0, and k3 equals 2. If we take n2 to be 1, we have k1 equals 2, k2 equals 5, and k3 equals 1. If n2 is equal to 2, we have that k1 is equal to 2, k2 is equal to 10, and k3 is equal to 0. You can't have any greater values of n2, so this is it. And other options, if we take n1 to be, instead of 0, choose it to be 1, then we have that k1 is equal to 6. We have that k2 is going to be equal to 2 times 1 is 2 plus 5n2, and k3 is going to be equal to negative 1 minus n2 plus 2 is negative n2 plus 1. And so if we take n2 to be 0, we have k1 equals 6, k2 equals 2, and k3 equals 1. If we take n2 to be 1, we have that k1 equals 6, k2 is equal to 2 plus 5 is 7, and k3 is going to be 0. We can't have any greater values of n2. If we take n1 to be equal to 2, we have that k1 is equal to 8 plus 2 is 10, k2 is equal to 2 times 2 is 4, and k3 is equal to, this is 2 minus n2 plus 2 is simply negative n2. And if we take n2 to be equal to 0, we have that k1 is equal to 10, k2 is equal to 4, and k3 equals 0. We can't have any greater values of n2, and we can't have anything less than 0. And we can't have any greater values of, well, let's see, we have 1, 2, 3, 4, 5, 6. Let's try another one. Suppose the n1 is equal to 3, then we have that k1 is going to be equal to 15. No, k1 is going to be 14. And k2 is going to be, this is 2 times 3 is 6 plus 5n2. And k3, this is going to be negative 3 minus n2 plus 2 is negative 1 plus 4 minus n2. And so we're going to have to choose the n2 has to be less than 0. Suppose the n2 is negative 1. Then we have that k1 is equal to 14. k2 is equal to 6 minus 5, which is 1. And k3 is equal to negative 1 minus negative 1, which is 0. We can't go any lower, though, because then k2 will be less than 0. And so these are going to be all our solutions. And the coefficient of x to the 46th is the sum of the coefficients for each possible combination. And this would be a very lengthy calculation. However, just notice that the coefficients for each one, this is simply going to be the total number of combinations we have, which is 7 combinations. In part D, we're asked to use our answer from part B to determine the number of ways 46 cents of postage can be pasted in a row on an envelope using 3-cent, 4-cent, and 20-cent stamps when the order in which the stamps are pasted on matters. So we have that in part D. Order matters. And so using our answer from part B, we have that our generating function is 1 over 1 minus x cubed minus x to the 4th minus x to the 20th. And we have that 46 divided by 3, lowest possible stamp is equal to approximately 15.33 and so on, that this tells us we can find all the possible combinations resulting in a term containing x to the 46th in the first 15 terms of our sum. So we want to expand the sum from k equals 0 to, and then 15th term of x cubed plus x to the 4th plus x to the 20th to the k. And here we want to use a computer algebra system. Using our computer algebra system, we find that the coefficient of x to the 46th is 3,240.